At its heart, autoscaling is all about having the right resources at the right time. And it comes down to a trade-off between cost and reliability. It's very easy to just over-provision everything, and then it will be reliable, but really expensive. And it's also very easy to save costs by starving applications, but then things goes down, and no one likes that. So it's all about how you react and how you add resources when you need them and remove them when you don't. Autoscaling itself goes back, obviously, long before Kubernetes. I think on Kubernetes, it's a little bit more complicated just because it's a much more dynamic environment. There's a little bit more going on, which makes it a little bit more complicated. It also opens up a lot more possibilities and like strategies to optimize. And then on Kubernetes, there's 3 flavors. So there's horizontal autoscaling. So that means if you have a deployment or workload and you have several replicas of it, as the load on the application increases, you add replicas, you give it more resources, you can handle more load. And then maybe it's nighttime, the load goes down, you can remove replicas and save money. So that's horizontal. Obviously, that existed long before containers. Vertical is about adding more resources, not by adding more replicas, but by making each of them a little bit bigger. So imagine you have 3 or 4 replicas, each which has half a core or 500 millicores. And you can go in and you can say, okay, maybe that needs 1 core, or maybe it needs 250 millicores. So about setting the actual size of the containers so they have the right resources at any given time. Horizontal and vertical autoscaling aren't new. The one which is new is cluster autoscaling. Because when you move to Kubernetes, you're running containers, and you have to have a cluster made of a variety of nodes, different types, different sizes, shapes, etc. That's where you need to actually understand how you're creating your cluster and adding nodes as you have more replicas and removing them. And that can get pretty complicated, which is where tools like Karpenter come in. The way that Karpenter works is it looks for unschedulable pods and then create nodes which will fit those pods. And then the way the scheduler is working inside Kubernetes, it's looking at the resources assigned to each pod to decide what size node is needed and if existing nodes have space on them to fit that pod. And then the key concept to know here is the concept of requests. So this is something that you can specify and should be specifying on all of your Kubernetes workloads. And that says how much CPU and how much memory does this pod need. So what StormForge does is it helps you set these requests. And I think there was a survey done recently by the OpenCost project. Over provisioning, so oversetting these requests is one of the main drivers for waste on Kubernetes. I think it leads to something like 70% of Kubernetes waste is people setting their requests to be too high. And you're probably asking, if it's so clear what the problem is, why are people doing this all the time? And the reason is everyone goes through the same journey when it comes to vertically sizing their pods and setting these requests. First, they don't set them. They go down at some reliable. Then they decide to set them, and they realize that if they have thousands of workloads, picking thousands of unique values is very difficult. And they just pick a few t-shirt sizes, everyone gets an XL, and they end up in the position on the left. So they have an extremely inefficient cluster. They turn on Karpenter. Karpenter will go in, it will eliminate a lot of the bin packing waste. But if you haven't actually right-sized the pods, there's only so much you can eliminate. And then StormForge will come in and set these requests automatically. And the reason we can do it when people have struggled to solve this in the past is because we have machine learning, which can pull the data straight out of Kubernetes, pick the right values for each workload, and then actually automatically apply them. So you take something which would have been very hard to do manually, and you automate it away. Just like Karpenter did for the old Chef runbooks to spin up nodes, etc. To do this manually is virtually impossible. And there is a tool built into Kubernetes, the VPA. It doesn't have widespread adoption right now for a few reasons. I think it's partly how the different sort of dimensions of autoscaling play with each other. It can tend to fight the HPA. And then the other issue with the VPA is it's not using machine learning. So it's just averaging past data, which gives you a decent estimate. But the question is it an estimate you can trust enough to automate? And then you run into what we call the sort of Saturday and Monday problem. So you get to Saturday morning, you're going to suggest what the resources need to be. You're going to look at the last 2-3 days. You'll look at Wednesday, Thursday, Friday, and you'll be like, oh, look, load was high during the week. This needs 1 core. And then it's Saturday morning, load is much lower during the weekend, and suddenly you're over-provisioned. You get to Monday, and it's the reverse. Monday morning, you're like, well, the load's been low the last few days, and then you under-provision, and then you have reliability issues, which is a much, much bigger problem. So I think it's just inherently the only way to solve this problem at scale is with automation, and the only way to actually automate is to trust the recommendations you're getting. It also comes down to just a human problem. You have platform teams who are building a platform in Kubernetes for their developers to use. And the platform teams are looking at the developers being like, why can't the developers set these? And then the developers maybe less familiar with Kubernetes. They don't see how this rolls up to actually cloud costs, and they're not incentivized to actually solve this problem. So they're looking at the platform teams to solve it. And the platform teams are like, I'm supporting 1,000 workloads. If I did this, it would be 10 full-time jobs. So each of them just sort of sit there staring at each other. And it's not clear there's a good answer to do this manually. We've seen many people try. I don't think we've ever seen anyone succeed at managing this manually.